Hello students, welcome back to my 7th lecture on basic maths. In our previous class we have studied Kramer's rule and with some examples. In this class we will study the very important concept, that is minor, cofactor and adjoint of a square matrix. So let's get started. We will see what is the minor of an element in a square matrix. So we have the definition of minor of the element given by if A is any square matrix. Remember, it has to be square matrix because we are discussing determinant here. Okay. So if A is any square matrix, then the minor of an element Aij of A is the determinant obtained by deleting the row and column of determinant A to which the element Aij belongs. Cofactor of Aij is given by the formula represented or denoted by A, capital Aij, and it is equals to minus 1 to the power I plus j, where I is the position of the row, which row it is the element lies, and j gives the column in which the element lies, into minor of Aij. Hence, the cofactor of Aij is the minor with proper sign. The signs of the cofactors of the element of the determinants of third order and second order are given here. In the determinant, we have 3 rows and 3 columns. So first sign of the element will be plus, second one will be minus, third element contains plus sign. Similarly, second row contains alternate signs like minus, plus, minus, and third row contains plus, minus, plus. Fine. And 2 rows, 2 columns of the determinant contains the alternate symbols plus, minus, minus, plus. Do remember this. For example, if A is given, that is equals to determinant with 3 rows, 3 columns, that is equals to minus 1, 2, 0, 3, minus 4, minus 2, 5, minus 3, 4. Then minor of 3 can be found by, where is 3 here? In second row, first column. So delete the first column and second row. Which all elements will remain, that you have to note it in a determinant. That is equals to 2, 0, minus 3, 4. Now solve this determinant by cross multiplying. 2 into 4 is 8, minus 0 of minus 3 is 0 only. So you will get minor of 3 is equals to 8. And minor of 0 can be written as delete the first row where the element contains, it is in the first row and third column, and remaining element you have to note it in a determinant order, that is equals to 3 minus 4, 5 minus 3, which is equals to 3 into 3 is 9 with minus sign, minus 9, minus into minus is plus, 4 into 5 is plus 20, 4 5s are 20. Now 20 minus 9 is plus 11. Similarly, minor of 2 can be calculated as delete the second column and first row. You get the determinant, that is 3, 2, 3 minus 2, 5, 4. Now solve this determinant. 3 4s are 12. Minus into minus is plus. 2 5s are plus 10, which is equals to 22. So this is how we have to find the minor of a particular number. And cofactor of 3 can be, see here, 3 contains minus sign because it is in second row first column. So there is a minus sign. See the pattern in the previous slide. So there is a minus sign. So here you will get a minus 8. Same pattern, just change the sign. Cofactor of 3 is where the element contains that sign you have to put in front of the number. Similarly, cofactor of 0, 0 contains plus sign. So the element will be as it is, that is 11. And cofactor of 2, 2 is in the second row, third column. There is a minus sign. So minus of 22 you will get as a cofactor of 2. Next, adjoint of a square matrix. If A is any square matrix, then its adjoint is the transpose of the matrix obtained by replacing every element of A by its cofactor and is denoted by adjoint of A or ADJ. That is a short form of adjoint of A, ADJ of A. That is, hence, if A is given, the matrix, square matrix with 3 rows and 3 columns, then adjoint of A, here we are doing the cofactor of each element, then replace A11 by capital A11 here. So that means the cofactor of the element A11 is A11. Okay. Similarly, A12 is capital A12. This is a cofactor we can say. And A13 is equals to capital A13. Okay. Then square matrix. Complete the square matrix. Put the bracket and write down T over there. You just observe adjoint of A is equals to capital A11 cofactor of each element from A11 to A33 to the power T, that means transpose of a matrix, is equals to, convert the first row into first column, second row into second column, third row into third column. So this is adjoint of A, where A11 is nothing but cofactor of A11, that is with plus sign. So how to do, we have done already in the second clip. So A22, A11 we will get by deleting the first row and the first column, and we will multiply the remaining element diagonally. That is A22, A23, A32, A33. Then you will get diagonal cross multiplication, that is A23, A33 minus A23, A32. Similarly, you can find the remaining. For example, if A is equals to A, B, C, D, then cofactor of A is deleting the first row and first column. Then determinant is D, that is equals to D. Cofactor of A contains plus sign, so it will be plus D. And cofactor of B is equals to, it contains minus sign, minus of C. Cofactor of C is equals to minus B. Cofactor of D is equals to plus A. Then adjoint of A can be written as, within a square bracket, cofactor of each element A, B, C, D will change, that is equals to D minus C minus B, A raised to the power T, transpose of rows as well as columns. That is equals to, first row is equals to, first row will becomes first column, second row becomes second column. So this is how we have to calculate. Note here that hence the adjoint of 2 rows 2 column matrix is obtained from A by, so this is just hint how to remember without writing these steps. You can directly attempt by remembering this small trick, that is interchanging the elements in the leading diagonal and changing the signs of the elements in the other diagonal, that is A into D. It is a leading diagonal. You just interchange them. A and D, you have to interchange it as D and A, and other diagonal elements you have to change its signs without their position. Don't change their position, just change their sign. If plus will be there, then make it minus. If minus will be there, then change it as plus. So remember, interchange the leading elements, change the sign of the other elements in the other diagonal. Hope you will remember by practicing it. This is a short trick for only 2 cross 2 rows. Directly you can attempt in the examination. Next concept, that is singular and non-singular matrices. If A is a square matrix, then it is said to be a singular if determinant of A is equals to 0, and non-singular if determinant of A is not equals to 0. For example, A is given with the square matrix 3, 6, 2, 4. Then determinant of A will be 3 4s are 12 minus 6 2s are 12 is equals to 0. Since here determinant of A is 0, therefore matrix is said to be singular. Another example, A is equals to 2 minus 3, 4, 4. Then determinant of A is obtained by multiplying the leading element and the other diagonal elements. That is equals to 2 4s are 8, minus into minus plus 3 4s are 12, that is plus 12, which is equals to 20. So 20 is not equals to 0. Therefore A is non-singular. We will see some more examples. Write the adjoint of A. It is given by minus 1, 1, 1, minus 1. You can write it directly using the hints as a note in the previous slide. Otherwise, you practice it. Cofactor of each element. That is, first you put all the 4 signs, that is plus in the first element, minus in the second element, minus in the third element, plus in the fourth element. Then delete the first and first column. You get the cofactor of first element, that is minus 1. After deleting minus 1, first column, you get minus 1. Similarly, second element, minus of deleting the first row and second element, the cofactor of 1 will be 1. Similarly, cofactor of 1 is 1, cofactor of minus 1 is minus 1. Okay, now open the bracket by multiplying with the signs in front of the number. Plus into minus is minus 1 into, second element is minus 1, third element is minus 1, fourth element is again minus 1. You can simply write it as interchange the leading element, that is minus 1 and minus 1 are in the first leading element. So after interchanging the sign, the same number only we are going to get. And second element, second diagonal elements are 1 and 1. If you change the sign, plus will become minus. So we get minus 1 in the other diagonal elements. So the second example we have done directly without writing the cofactor of that. Means we have skipped the step by remembering the hints. That is, adjoint of A is equals to first diagonal, you see leading diagonal 1 and 0 are the two elements in the leading diagonals. You just interchange them. In place of 1 you replace it by 0, and in place of 1 0 you replace it by 1. 1 and 0 will interchange, and minus 3 2 sign will change. Minus 3 becomes plus 3, 2 becomes minus 2. Understood? Third example, if A is equals to 1 2 3 4, B is equals to minus 1 0 0 1, find adjoint of A into B. First, students, find the product of A and B. You get 1 2 3 4 as A into minus 1 0 0 1 as B. When you multiply first row with first column, you get first element. That is, minus 1 into minus 1 is minus 1, plus 2 into 0 is 0. Then first row with second element, you get 1 into 0 is 0, 2 ones are 2. Then second row with first column, second row with second column, you get 3 into minus 1 is minus 3, plus 4 into 0 is 0. Then 3 into 0 is 0, plus 4 ones are 4. Then you get the matrix of a product A into B is equals to minus 1, 2, minus 3, 4. Then adjoint of AB is given by interchange the leading element minus 1, 4, you just replace, interchange them, you get 4 minus 1. And other diagonal elements change the sign. Plus 2 becomes minus 2, minus 3 becomes plus 3. Hope you are getting, students. Another important sum, it will come for 5 marks in part D. If A is given, that is 1 3 4 5, prove that A into adjoint of A is equals to adjoint of A into A, which is equals to determinant of A into I. I is a unit matrix of order 1 0 0 1, 2 cross 2. So first solution is find the adjoint of A, that is interchange the leading element, that is 1 5 becomes 5 1. Then sign will change for the other diagonal elements, that is minus 3 minus 4. Then in the first there are three parts. A into adjoint of A is the first part. Solve for this. A into adjoint of A, multiply A with adjoint of A. So write down matrix A, then adjoint of A, then follow the same steps. That is first row into first column, first row with second column, second row with first column, second row with second column. If you do it properly with the signs, then you get the answer as minus 7 0 0 minus 7. This is a first part answer. Similarly, second part answer is second part A adjoint of A into A, the reverse part of first part. So you get, write down adjoint of A first, then write down A matrix. So after multiplying these two matrix, you get minus 7 0 0 minus 7. So this is second part. The last part is determinant of A, find it, you get 1, 3, 4, 5. Crosswise you have to multiply. 1 into 5 is 5 minus 3 4s are 12. You get minus 7. So it has to be multiplied with I, that is a unit matrix. 7 into minus 7 into 1001, you get minus 7 0 0 minus 7. That is your third part. Here they have asked to prove that A into adjoint of A, that is equals to adjoint of A into A, that is equals to determinant of A into I. Here we got the same answer in all three parts, hence the proof. Next example, find the adjoint of a matrix, let it to be A, matrix A, which is equals to 1 4 minus 2 minus 2 minus 5 4 1 minus 2 1, row wise respectively. So here in case of 3 cross 3, we don't have any shortcuts. We have to follow the steps given. That is, find the cofactor of each element. All the 9 elements you have to find like this. Adjoint of A is equals to, the first important step is, here you write down adjoint of A, which is equals to, write a big square matrix with blank elements raised to the power t you have to write. Then inside the square bracket you have to write plus and determinant sign. Plus and determinant sign. First element. Second minus determinant sign. You first write down all these terms first, that is adjoint of A within a big square bracket raised to the power t, and under this, in this, plus of the determinant sign, 4 elements have to fit, minus of the determinant sign, plus of determinant sign in the first row. Similarly, leave some space and write down the second row with alternate signs minus plus minus, and third row with plus minus plus. This is one of the short way. Immediately we can calculate the determinant. After this, write down the first determinant elements. They are, see, cofactor of 1 we are finding. So it is in the first row and first column. Delete it. In mind only you have to delete. 1 4 2 and 1 minus 2 1 are in the first row and first column. Leaving that, which are elements will remain, that you have to write down here. That is minus 5 4 minus 2 1. Similarly, cofactor of 4 is, delete the first row, second column. The remaining elements are minus 2 4 1 1. Okay. Then third element in the first row, that is of minus 2, cofactor of minus 2 is equals to, delete the first row and third column. You get the elements in the determinant are minus 2, minus 5, 1, minus 2. I hope you are understanding the cofactor of the first row by deleting first row and first column, second column, third column respectively in the first 3 elements of the adjoint of A. So similarly, you can practice for second row and third row. After doing this, you get adjoint of A is equals to, you have to solve the determinant, that is plus of 5 into 1 is minus 5, and here plus 4 into minus 2 is, minus into minus will become plus, that is 5 plus 8. minus 5 plus 8 is equals to plus 3 in the first element after solving for the determinant. Then second one, you have to, if you want, you can do the next step properly. Here in this sum they have given directly, so you can try it in the by writing one more step. Then minus of minus 2 into 1 is minus 2, 4 ones are 4, minus 2 minus 4 is minus 6, minus 6 into there is a minus outside, so minus minus becomes plus 6. Similarly, third element in the first row, minus 2 into minus 2 is plus 2, sorry 2 2s are 4 plus 4, minus, here there is a minus sign with minus sign in 5 in front of 5, minus 5 into 1 is plus 5, there is already minus sign when you solve for the determinant, so you get 4 plus 5, that is equals to 9. Okay, these are the first three elements in the first row. So you can solve for the second row and third row. Then here there is a T transformation from the first row to first column. Okay, you are observing? Okay, then adjoint of A is given by, after transforming the first row, interchanging the first row into first column, that is 3 6 9, first row becomes first column, second row becomes second column, third row becomes third column. So this is how you have to find the value of adjoint of A of 3 rows and 3 column matrix. You need little practice for this. Next one, find x if the following matrix are singular. So first one, 2x minus 9 minus 4 5x. Here they have asked if it is singular, then find the value of x. So assume that it is a singular. Determinant of A you have to find. So by definition, if determinant of A is equals to 0, then matrix is singular. So determinant of A you have to find. So 2x minus 9 minus 4 5x is equals to 0. In the question they have given already that matrix A is 0, singular, so it has to be equated with 0. So multiply diagonally, evaluate for the determinant. 2 into 5 is 10, x into x is x square, minus, here minus 9 minus 4 is plus 36. So already there is a minus sign when you solve for the determinant, so you get minus 36, which is equals to 0. Now shift minus 36 that side, and it is divisible, both numbers are divisible by table 2. Divide it first. 2 5s are 10, x square is equals to 2 18s are 36. Then x square is equals to plus or minus, divide both the sides by 5 and take the square root, you will get the value of x. Next one, same question but different matrix. You have to find the value of x. So given matrix is singular and hence find the determinant of this and equate it to 0. 3 2x 4 1 minus 1 0 3 4, that is equated to 0. Expand in our earlier method. So 3 row wise we are expanding. 3 into, delete the first row and first column, the remaining 4 elements you have to multiply with it. That is 1 into 4 is 4 plus 3 into minus 1 is minus 1, minus minus becomes plus. So here 4 plus 3 you get. then minus 2 into, delete the first one, second column, 4 4 is 16, minus 1 into 0 is 0, plus x into, delete the first row and third column, you get 4 into 3 is 12 minus 0, which is equals to 0. Next, simplify this row, this step, you get 4 plus 3 is 7, 7 into 3 is 21, minus 16 2s are 32 with minus sign only, plus 12x, which is equal to 0. Then subtract 32 and 21, you get minus 11, shift it to the RHS, you get plus 11. Then the value of x is equals to, divide both the sides by 12, you get the value of x is equals to 11 upon 12. Students, with this I conclude. We will meet with more sums from the exercise. So you do practice all these sums again and again. If you have any queries, you can message me. Thank you.